Okay.
Sorry, I forgot to
But
record.
and the thing is, when we want to summarize all the data, is it correct?
Yeah, very much so as well. So
Yeah.
especially if, okay, I'm the teacher and the average score of the students altogether was 80, which is a pretty high score, which means I'm a teacher, I'm doing pretty good. My boss probably would be thumbs up. But if the average was low, like 50, 60, meaning that's a low average, means the constant number together is probably around, well, it could be a mix, but there's a lot that's around 50, 60, or even lower. Okay, so great answers. And let's move on to what does median calculate? And Sal, you can choose the next person to try to answer. If you don't know the answer, you can just pass. But Sal, you can.
Okay, only one left. Pierre. Come on.
Peter, you want to try? What does median calculate?
You mean you want to know about the calculating, how to calculate the median, right?
Okay, yeah. How do you calculate it?
That's the median. Median is the midpoint of the value. For example, we have the range of 1 to 10. So the midpoint of the range 1 to 10 is the median.
Right, perfect. Thank you. Great explanation. So yeah, it's the middle point in the list or the data list. Okay, so that is median. All right. So now we have this question is an additional question. How can the number of data points, or another way to say data values, affect the median? So let's say you have odd amounts of numbers or data points in your list, or you have even. So how would you know what to choose, or what is the median for those types of situations? And after that, can you try to choose somebody?
Let somebody else try it first.
All right. Does everybody want to try? Just let me know. Just think about it. I'm sorry I didn't show you the numbers, but I'll just, yes, Mr. Visal?
No, I just want you to put it in different way. I mean, the question. I don't really get it.
Okay.
What do you want to?
Yeah, let's say I have 3 numbers, 1, 2, 3, right? And is that an odd number or even number?
It's the odd number.
Yeah, so the median would therefore be what number from 1 to 3?
Exactly 2.
Yes, but what if you had an even number like 1, 2, 3, 4? What is the median number now? Because it's even. Oh yes, Mr. Esme, you're correct. You said it really quick and you left. Yes. Could you say it again because it was really quick?
I think median number for that is 2 and 3 together. Yeah. 2 numbers.
Correct. So now you know. Who can summarize for me therefore this question? How would you answer it in a full sentence? So since that's may already kind of answered, Visal help. Maybe after that, Mr. Keon could try to summarize what we just talked about to answer this question.
Yeah, so how can the number of the data points value affect the median and the even? So I would say it's between the odd and the even, so that it cannot be, it cannot be exact or accurate in between these two, that somehow. And that's how the data point works when you see it in the data set itself.
All right, thank you. That's a pretty good explanation. Anybody else want to add on top of that, or everybody okay? All right, pretty okay. All right, yeah. So we want to say that when you are going to calculate a data set and the data set has odd number of data points and you use the median calculation, you know that you're going to get one median or one output, right? But if your total number of data points or values is even, like 100, or sorry, let's go back to a 4 or 8 or a 10 or a 12. We know that we should get 2 median points because it's an even number, okay? And odd, you always get 1, even is 2. So that's basically the summaries. That's what's gonna happen, okay? All right. Okay, so here, let me give you here the answer. If the number of data points is an odd number, you only take the middle number. If the number of data points is an even number, you take the 2 middle numbers, okay? Or the 2 middle data points. All right, good. Okay, so what is standard deviation? Standard deviation, who wants to try this one? All right, so does anybody know what deviation means? Deviate.
I think maybe it's the spread of the distribution. It's a gap. So
all right.
a little bit, so it's becoming like a little gap.
Yes. So to add on, deviate means to be away from the middle or be away from the group. So you deviate away, you go in a different direction. So standard deviation is a measure of the amount of variation or changes of a set of values. So again, when you're saying if they're spread out and they're not close together in the middle, then we have a deviation. And you can get specific numbers for those, but we won't go deep until we move into Excel. Now, a low standard deviation, maybe like a low number, indicates that the values tend to be close to the mean of the set, okay? So, Mr. Resmay, what's another word for mean?
Again, please.
Yeah, what's another word for mean? Or what does mean do? It calculates starts with an A. Think back to what, yeah.
I'm not clear about your question. Not hear it very well.
Yeah, sorry about that. So the mean, what does it mean? What's another word?
Okay, you continue.
Yeah, so what's another word for mean? Meaning, remember when I was talking about the teacher scenario? So I want to find the mean of the score. But another word for mean is what?
Average.
Yes, perfect. Thank you. Sorry, I made that question really complicated, but yes, we're trying to, it indicates that the values tend to be close to the average of the set, which is the mean of the set. Okay, that's when you have a low standard deviation. And in Excel, you have a formula or actually a function that you can use that calculates it for you. Okay, so if you get a low number, then it's just telling you that they're close to the mean, all right, which should be a good thing, depending on what you're trying to do. Now, if a high standard deviation indicates that the values tend to be away from the mean and are spread out, okay? So if you get a higher number, then they are not close together, they're spread out, all right? Okay. So if you ever need to take screenshots, let me know. If not, then okay. So what is mode? I think I told you the answer already. Who wants to try?
What is that? Is this a model that we use for the thinking, the style, the method, the method that we use for doing calculation?
Yeah, it is a method of doing calculation, but it doesn't really create a model. It's just a way of to calculate what? Who can help? Or to show the most frequent what? Or the number that is shown the most or the least?
Most.
Yes, the most, okay? So if you have a data set from, like you have a data set with 8 different numbers, and a lot of the numbers, or 5 of the numbers are number 3, then the mode is 3 because there's more number 3s than every other number in there, okay? So that's what it means, mode. Mode is 3. So mode is the value that appears most often in a data set of data values. Okay? It appears most often, like that number 3, right?
Okay, I got it. A previous slide, please, because the previous slide, please. I have the question. I'm not so clear that if we have the low standard deviation, it's good, or we have a high standard deviation, it's good for us. And to show it that our data is primarily correct. I think, yeah, you understand what I mean?
Yeah, so really depends on what you're trying to do. If you're trying to, I think I could put it in the context we're talking about the exam scores. If the average was, wait, let me think. Let's say the average was 80, okay? And the standard deviation score would be actually pretty low because it indicates that most of the numbers are really close to the mean, which is 80, okay? So it means that a lot of the scores were really close to 80. So it has a lower standard deviation score. Or if it was high deviation score, it could mean that the numbers are all over the place, okay? But the average was still 80, all right? So meaning like some people could have got 100, some people could have got 90, some people got 20s, 30s. But if it was a lower standard deviation score, they would be really close together, meaning that very like the same number almost, or in the ranges, okay? Okay, cool. Yeah.
So I just would like to clarify a little bit when it is, I mean, the number is less and close to the mean. Is it the better result that shown in the data?
Yeah, for the most part, it is what you are looking for, because when there's less deviation, it means that there's less outliers, or there's less changes, or there's less problems in the data that you would look for. Or I'll try to explain this as best as I can, but for the most part, you do want a lower standard deviation.
Right.
And it does tell you that it's a good thing. So if you don't have a high or a low standard, then there's something wrong with the maybe the campaign that you're trying to do. Like let's say the campaign is to get a lot of people to buy a product, or the campaign is to get the average age of people in a certain area. And if you have a low standard deviation, that means that, let's say, one area has people that live that are very the same, close to the same age, right? But if you have a high standard deviation, then it means like there's a lot of people with different ages, right? But in that case, you're not really. It's hard to say in that case what's better. It really depends on what you're trying to do. So I couldn't really explain that correctly. But for the most part, yes, standard deviation, when you get a lower score, it's better. But it also depends on what you're trying to do.
So you mean that it is it is a peak sale when it is a less standard deviation spread.
Yeah,
Like a peak.
yeah,
Thank you.
yep. I'll try and explain it more. I guess I'll try it tomorrow, but thank you for the question. And if I confused you, I apologize. Okay, so here we go. We're going to go to the second category, which is what are examples of running models? Now, these examples of running models, we're not going to go in depth with them because they actually relate to machine learning and also algorithms. But at least if you know one or two, it's good for you. And it's not all about machine learning, but for the most part, you'll learn more about it. So one is linear regression. And does anybody know the second one?
Yeah, the first one is linear, another one is unlinear. It's been seasoning, or I'm not so sure. I see something like statistic study and business forecasting.
Yeah. All right. So the next one, it might be what you said. This unlinear could be this one. Logistic, I think you said that as well. Or maybe you did, I don't remember. A logistic regression, okay? So we won't go into them, and you could ask me, but I really can't tell you until we get to the later stages. But yeah, these are examples of running models, and you have to use one or the other for different purposes, okay? But again, we will go through them a little later. Okay.
But for linear regression, I think that last time I did use Excel to do it, right?
Yeah.
Okay.
I believe Excel has the function which we should be able to go through once we start.
Okay, it means that last 10 years I did learn about it.
Yeah.
For 6 months and 2 hours for 1 day, for 1 week, 2 hours for 1 week.
Nice. Okay, nice. All right, so does anybody know the different plot types? There's a lot, but can you think of any?
Histogram.
Yeah, that's one. Histogram, anything else?
Box plots.
Yeah, box plot is number 2.
Scatter plots.
Yeah, 3.
Line plots.
Yep, correct. 4. Yep, bar plots. All right, we got a lot of them. Nice. Sorry, what was the last one you said?
Path plots.
Again?
Paths.
Can you type it in there? Sorry, I can't hear very well. Type it in the chat.
Maybe I am wrong, but this is for plot.
Okay. Did you send it in the chat or Telegram? Did you? Okay, I didn't hear what you said, but you're probably right because you were right 5 times in a row with the box. Okay, I'll just show you the simple ones, and one is the scatter and histogram and we have bar. There's many more, but those are just examples of the plot types. Okay, so now we're going to move on to this concept called variables, and there's 2 types of variables. And does anybody know the 2 types? They both start with the letter C.
Some continuous and categorical variables. All right.
Yes, correct. Those 2. Right. Was that accurate? Did you say that? Yeah. Okay. All right. Great. So yeah, those are the two. Now we're going to. Okay. Yeah. So those are the two, and we're going to dive a bit deeper to identify what they mean. And let's check this one. Let's see if you can get this one. So colors, countries, and industry are data types that belong to which variable? Which variable? Is it continuous or categorical?
Industry is categorical.
Categorical. And can you tell me or ask somebody why it would be categorical?
It's a text.
Yes, it very much is a text.
Country is also text.
Yep, and it's more of a feature or attribute. All right, so because of that, we call it categorical. Yes. So I'll give you some more questions later just to solidify that in your brain about the concepts. So what are examples of continuous variable? A continuous variable.
Continuous more is on numbers.
Numbers, yeah. All right, and Gia, I'm sorry. Could you ask somebody what could be an example of a continuous variable that uses numbers?
So, Apiria, what are examples of the data in the continuous variable?
It's as we can use it as head, the head, the temperature, and let me try to remember.
Yeah, those are right though.
Too many heads and temperatures, and as we can use it as it is the revenues.
Okay, did you say revenue?
Yes, revenue.
Okay, what do you mean by revenue? Do you mean like the money that you make?
Yes, the money, the loan, salary, or wage, or anything else.
Okay. Does anybody want to add or disagree or agree? If profit is a number, is it a category?
I think it's number continuous, it's right. Revenue show number, it can goes up and down, it has scale.
Yeah. All right. So I believe if what you said was profit, then it should be continuous as it deals with numbers and it has low and high extremities, meaning limits. But the other ones you said are super duper correct. Or actually, you are right, revenues, but I think it must be used in a different context. Sorry, guys. Heights, temperatures, and revenues, but I believe it might be used in another context. So I'll have to get back to you on that one. So yeah. Okay, so if we go to this question here, what is the difference between age group and age? Which one is categorical and which is continuous? And who wants to try this one?
I think age is continuous.
Age is continuous and age group?
Age group is categorical.
Okay, could someone give me an example like of an age group or the different age groups?
It's kind of hard to give you because age, of course, is a number. So
Okay, but
when you talk about age group, it's just a combination.
okay. You could also say, let's say, if within the age group there were 3 groups, and one group was, we could say, seniors, right? And yeah, depending on what their age group is, but we could say that if they're, let's say 60 to 80 or higher, 50 or higher, we could say that they are senior. So their value now is senior. So it's text senior, right?
Yeah.
So if they were adults, they would be at another age range, and their value would be adult. If they're a child, there would be another age range, right? So yes, you're right. It is a range, and depending on that range, it would have a value, or sorry, a categorical value. Okay, so yes, you are right. Age is continuous. Age group is categorical. Now let's try this one. What is the time or difference between time and month of year, which is categorical and which is continuous?
So yeah, again, time is continuous and month of the year is categorical.
All right, yes. January, February, March, April. All right, that should have been an easy one. And now let's try, based on some of the questions you did in data camp, if you did them. We have, which variable does this example belong to? Percentage of questions answered correctly. Is it categorical or continuous?
Categorical.
Categorical, all right. We have categorical. Anybody else?
Yes, categorical.
I think it is the
Continuous.
continuous.
Okay, and so can we ask why do you say continuous? It's numbers, yes, but why can't it be categorical?
Yeah, maybe I am wrong, but it's a percentage. So is percentage is a number?
Yeah. So the final number or the final output would be a number, right? It would be, yeah, percentage.
Yes, I changed.
Yeah. Okay. Great. So yes, continuous. And let's try this one. Was the exam passed or failed? What do we think here? Let's try Mr. Ratsman. Is it passed or failed?
I think it's categorical.
All right, you think it's categorical, all right? Because I heard think, so I think you're probably 70% sure, which is still good. Next, Mike, can you choose somebody else to answer what their thoughts are on this question?
Answer it without.
It's categorical.
Okay, categorical. Okay. Does anybody want to say continuous? I will give you 3 points. All right, after that, you raise your hand.
I still confused sometimes between the meaning of continuous and categorical. Can you give me a tips to remember clearly? Can I distinguish between the meaning of continuous and categorical?
Okay, one thing you could do is look at the vocabulary in the question. So, for instance, in this question, it
Sometimes I
doesn't.
think it is the number. Sometimes I think this is the number.
Yes.
Category. But I think it is the number. Although it's not so the number, but only two answer. Pass or fail.
Yes. Exactly. So that is one thing to check. What May said is it either a pass or a fail? If it's a pass, then it would say pass as the value. If it's failed, then it would show failed as the value. But the number that dictates if it's a pass or a fail is set by the user or whoever's creating the evaluation. So if you, the evaluator, says 50 is a pass, then if that student meets the criteria, the value of that column that says pass or fail is going to be passed if that's what you said. Okay. And then when you count all those how many passed, then that's going to be that's going to be a number, and how many failed. But originally it is a categorical data, right? Either in this sense, 1 or 0, pass or fail. But sometimes it could be different selections, like for instance, colors, right? And if you choose, there are many different colors, and if the person chooses like red, another person chooses blue or green, right? But it doesn't really deal with, when we're talking about continuous data, where there could be decimals and there could be large numbers, you can multiply them, and different calculations can be done. So yes, it's categorical. Let's try a few more, and if I see or if you ask for more examples, I will give you more tomorrow. So species of squirrels. Species. You say that again?
I raised my hand.
Okay, yeah, go ahead.
Yeah, sorry. I mean, just go back to the pass and fail.
Okay,
so
yeah.
It's all about like you said just now about text or sort of that thing. But if we are realizing that the reason that makes you fail is less than 50%, for example, so that is based on the calculation, isn't it?
It can be based on, it's actually based on you or who's ever setting the criteria of a pass or a fail. For example, in some states in the United States, they have different pass fails for in their schools. So for example, in one school, they could say 60 is a fail. Another school could say 50 is a fail. So you as the evaluator could say, okay, 60 is a fail, 60 above is a pass. Then you would say that student who got 61 passed, okay, or 65 passed, and the student got 59 failed. So in that sense, you distinguish, or you are the one who marks it and says it's a pass or fail.
So what I mean is this: it doesn't matter in the States or anywhere in the world, so it can be different to pass and fail to the score. But let's say fail or pass. That means based on the calculation with numbers, so that you can sort, okay, the students is fail and the students is pass, right? So deeply calculating with a number.
Mm-hmm.
So its relevance before you say fail or pass, I mean, you did some calculation. Why is this one is not continuous, instead it is categorical?
Okay, so it's categorical because the actual data is going to be text. So meaning, for example, if you're in Excel and the category or the value of it says passed, it doesn't say 10, it doesn't say 5, it says passed, so it's text value. And because of that, you can't say it's continuous. So we're talking more about the actual data and the data type. And that data type is not a number, it's a text. So you could say that if it's a pass, then the letters PASS in Excel is therefore a categorical data, meaning that it's text. Does that make sense?
Data type is text, it is not
a number. Yeah.
I see. Thank you.
You're welcome.
So this tells by the system in the data itself.
Yep.
In the analysis.
Yes.
The program, okay.
Okay, what about species of squirrels?
Categorical.
All right, categorical. Anybody else?
Me either categorical variables too, because I think it's the group of things. And yes,
Yeah.
this is
All right, and do you want me to give you another example? So let's actually think of an animal that has different species of it. Or let's try insects like ants, right? So ants, there are different kinds of ants. There's like fire ants, army ants. And when you have, let's say, one column and you have information on that one ant, it's gonna say either it's an army ant or it's a red ant or a fire ant, right? So if you said categorical, you'd be correct because that value would say either a fire ant. Okay, so that's the value. It's a species of fire ant. All right. Okay. Does anybody want to give me another example instead of an insect or an animal? What kind of group could you use as a categorical data? Something that maybe you drink every morning if you're sleepy.
We have gender, we have male and female.
Yeah, male or female, yeah, because inside the value, it's going to either say male or female or M or S, right? Okay. So it is categorical. All right, I'm going to move on to the next one. I think it's another question. So population of towns in Canada. Population of towns in Canada. What do we think here? Or let's try Mr. Guillaume or let's May. What do you think here? Population of towns. So there's many towns in Canada, right? So we're talking about the population of each town. What do we think? Is it categorical or continuous?
It is categorically called.
All right, categorical for that slide. Mr. Kian, what did you say?
I think it's categorical.
All right, and do you know why?
It's actually, this is a large data set of the population within towns of Canada itself.
Okay, let's try this one. In Cambodia, there are many provinces, right? If I said the province name of this column for Excel, and then one cell said Praiwen, one other cell said Siem Reap, the other cell says Phnom Penh. So are those continuous or categorical data types? Categorical, right? And beside it has the population. And let's say in Phnom Penh it's 3 million and Praiwen it's 100,000. So that data for population, is it categorical or continuous?
It's continuous.
Continuous.
Yeah, okay, so it's continuous, right? So if this said different towns in Canada, right, it didn't have the word population, because when you think of population, it already tells you that it's going to be a number, right? So because of that, we can say it should be continuous.
So this is going to be continuous?
Yes. But I think in data camp, there was another one that says like provinces or cities or maybe towns in Canada, but it's asking for categorical data. But this one's asking for continuous. All right. Is it okay if I move on?
Yeah.
Okay.
Okay.
And
Yes,
if you do
yes.
feel like you need more practice, just let me know and I'll try to review some more tomorrow. So when you should use a histogram, okay? So does anybody know when you should use a histogram off by the top of your tongue or your head?
Yeah.
Okay, did you say something?
So histogram can show me for a better look.
Yes.
It
And
can show thousands of meanings.
yes. And also there's a key word here. During my cohort, they asked us this too. And they're like, when should you use it? And when do you know when you're looking at a histogram? Do you know when you're looking at a histogram compared to a line graph or a line plot or a scatter plot? How do you know when you're looking at a histogram?
We need to look to the outliers.
All right, that's one point. Yep.
Yeah.
Yep. Great. That is one point, and we're gonna keep that point there because it's totally related. And the one word is, actually it's not two words, there's 2 points. One is if you have a single continuous variable, okay, so if it's telling us that you only use continuous variables in a histogram, then you wouldn't use what? If you're using continuous, you're not using what type of variable?
It's actually decreased or increased.
Okay, yes, it's increasing, decreasing. So in this, if it's saying this, we won't be using categorical data with the histogram. Now, if you want to ask the shape of the distribution, okay, of its distribution. So this is more of a question about how does the histogram look? Again, there's different shapes that we'll go through, but again, you should use it when you want to know the shape of your data, okay? And your data is continuous data, so it's numbers, all right? Now let's go a little bit deeper. So this one's a trick question, not really tricky, but what is another word for peaks? And it was in chapter 1. There's another word for peak. Yeah.
Sorry, please go on.
It's a technical word.
Yeah, peak it is just only one. It's a unique histogram.
All right, you got the synonym for it. Very good.
The highest points of the histogram.
Yeah. Okay. And the word that relates to peak starts with an M. M-O-D.
Modality.
Correct. Modality. Okay. So that is the word that I need you to try to remember. Modality. And it also relates, or the easiest way to say or to understand it's the peaks. All right. So what Peter and you said, the top or the highest point in the histogram, right? So modality. Okay, so after that, I didn't see you raise your hands. I think you knew the answer, right?
No, I just want to say that peaks is modality.
Okay, nice. All right, modality, peaks, and P. Try to remember that if you can.
Yes.
And what kind of modal is this? I think Mr. Kian, you may have said it. What kind is this?
Yeah, this is a modality, the peak.
Yes, yeah, you see the peak at the top. Now there's a specific term or type for this. If you look how it is formed or the shape of it, it starts with a U. You said it. I think it was.
So it's like a curve, isn't it?
Yeah, and kind of like a curve. And start with the U, the correct term for it.
Uni model, all right?
Okay, yeah. So Mr. King, you said this too. It is a uni model, right? And that's the term used for it because of how it's just one. There's just one of the peaks. So if I showed you this, what would this be?
Two
The
peaks,
term,
peak, modality.
yes, bi meaning two, like a bicycle, two wheels. So this one has two peaks. And this one, the next one, we have, what is it?
Modality.
Okay, yes. It's a tri because we have three. All right. It could go on and on. However, we're not going to talk yet about when you might have them or why they might happen. We're going to actually do it as a quick group and see if we can figure it out. And we're going to, let's see, there's 4 of you, so we can do 2. And you're just going to try to answer these questions as best as you can and present your answer. So what would cause a unimodal distribution? Okay, why would that happen? Or why would you have one? And what would cause a bimodal? And what would cause a trimodal? Okay, so we do know that these are different models. Is there a specific reason when we see 2 peaks or 3 peaks or just 1 peak? Okay, so that's what we need to try to figure out within maybe 10 minutes or so. Just search and talk with your partner, and we can discuss further. So I'm going to put you into break rooms, and it'll be random. So there'll be 2 rooms, be partnered up with somebody, and you just need to work together to try to answer these 3 questions as best you can. Or maybe you can answer it in just one answer, okay? So let's try. So we have Mr. Visal, and after that, Mr. Kiam. Is it Kiam or Kang? Sorry. Kiam. Okay, Kiam and Mr. Rasman. All right. Is everybody clear about what needs to be done?
Yeah, just try to answer
Yeah.
this
Okay.
question.
Yep.
In group.
Yeah, clear.
Okay. So go ahead, go with your partner and have some fun. Debate if you need to, and we'll come back in like 10 minutes. Mr. Kiam, I think there's a button you can, I don't know if you have an internet problem.
No.
Hello.
The time is over. I'm trying to engage with my teammates.
All right, nice. Okay, so let's see. Who's gonna share first? Just let me share my screen first. Okay.
Up, can you do it?
Wait for the slide. So
All right, you see my screen?
yes,
Yeah,
you-
yeah.
All right. All right, let's see what the wheel chooses. And just share your idea and we'll see if anybody, if they relate with the other group.
Spinning like a roller coaster.
Yeah.
Wow. Winner.
All right, just 1 second. Let me get back to my slide. Here it is. Okay, so Mr. Kian and Rasmain, you can both answer together or whatever you want to do. Just give us your idea.
So Rasmai, do you want to go ahead?
Father, can you answer it first? I'm not so quite understand.
Really?
Yeah. You go first.
Wow. Okay, so I mean, talking to the unimodal,
Huh?
the unimodal distribution. It means there is a single data value that, I mean, occurs with like high frequency as in the model, with the one point up. So it's actually a data value that ties for, I mean, having a high frequency. So that's how you tell about it. And also, it is the same thing with the bimodal. So it's again how I mean the data value occur, and then it's all related into it, so that you can see how the data perform in your analytics with that two distributions. And it generally ties together. So one or two, you can see, I mean, the straightforward, okay, is one model or two model. And then again, what we call the tri-modal distribution, again, the same. It's just only you can see three in the histogram. That's all I have. If you want to add something, so go ahead.
Okay. Yes, I want to add something about it. For me, I think what would cause a unimodal distribution, it is related to the kind of nature business. For example, for the student, if we sell the student cert, student book, yeah, mostly it is a unimodal, because during 1 year we have only one peak season, and yeah, like on the October we open the school, so that's why for about the September from August is vacation. So about the September, October, they have many family bring their children to go to the market to buy the shirt for the student. So that bring the unimodal for this model. Another one is bimodal distribution. It is related to the two kind of business, two kind of that you have very high frequency for that time. Example for there are two example. The first one is for the student. Why there are many students pass the exam, and there are also how many students fail to the exam. So, and another example is for that in Cambodia about the tourists. Why in the rainy season many people go to the place that have water, and for the hot season many tourists go to the Angkor Wat. So they have very high two distribution as well. For about the three-modal distribution, I didn't find the answer yet. I don't know. I cannot find the answer. I think three-modal distribution is about the multimodal distribution. What are the?
All right, thank you, Wesley and Mr. Kian. Wesley, your answer, or sorry, your question is a very good question, but it also relates to what you were talking about, bimodal, and we'll get to it in a second. I just want to give the other group some time to explain as well and see if it overlaps. So, Mr. Pineda and Visal, if you want to give us your answer and your interpretation.
Hello, Pira. Can do it.
Yes. Yes. What would cause three of these type of distributions? The first, I would like to talk about unimodal distributions. It is the one peak, or as we can say that there is an increasing in our graph. In any graph, for example, we're looking for the US dollar values or prices, and as we see, the first we have to look at the visit the time of periods. If we watch from if we visit from 2015 to 2021, and there is one peak. There is one peak during 2015 to 2021, and that the meaning of that peak is the increasing values of US dollar. So what would cause unimodal distributions? As we know, it is the one peak. So so I can say that the reasons of that is the increasing of the value of US dollar, and but only one time during the time we visit. That is the unimodal distributions. But the next bimodal distributions, if we visited and we saw there are two peaks, it means there are two increasing, there are two time of periods of increasing the value of the US dollar. So during the 2015 to 2021, there is two times of increasing that can be called bimodal distribution. That can call the causes or the reasons of originating of bimodal distribution. And then the third question is causes of trimodal of distribution. During, as the same example, during 2015 to 2021, there is three times of increasing the value of US dollar. So there is three peaks, and as we can say, that is the trimodal distributions, because there are three peaks, or there are three times of increasing. All of these questions, it's depending on a questions that I think how many times of increasing the values in the graph. Thank you.
Okay, I have another answer for the trimodal one now. This is about the, like, now we have the three kind of business. Like in the one company, they have sell, one is coffee, another one is Milo, another one is Nestle. And after that, we have the data of the three kind of business, and we see the data that about the sale profit for the product. And after we see the three data, and we think about the cost, we see about the margin, and so that's why we give the solution option that, oh, we should choose only sell the Milo, because Milo make a lot of profit and yes, more benefit than the other two. I think this is my thing of the trimodal distribution that we can compute to the business. How about Visa? Do we have another answer? Add in something?
I think no for now, because the question itself is quite tricky. trying to relate it with what we just learned, like a mode or median, standard deviation, but it evolves around mode. But when Pirat just explained me, it doesn't seem that it's the right one. But again, my answer is still the same as Pirat said. Depends on how many times the highest value happen. That's it.
Yeah, I also don't know the answer. I did search the Google. I just combined with the business knowledge that I did before, and combined with the last 10 years that I did learn. That's this, I have the solution for that.
Okay, thank you everybody for your answers. And I believe everybody touched upon the main point. And I do also want to clarify that, one second here. Just have to fix my computer. Okay, there we go. So I'm just going to give you more of context again with education, because I know that best. That's where I'm coming from. And in terms of business sense, I wouldn't be able to give you the best example, but we could ask, or I could ask one of the hard skill teachers to give that. So in thinking about, again, the exams, so let me start with this. Bimodal or trimodals can occur when there is more than one group in your data, and it's created by having more than one mode. Okay, so excuse me for my spelling there, but yes, when you have more than one mode. So what's a mode again? You can tell me what's a mode again?
It's a mode is the same number that happen many a lot of time in the data.
Okay, so I believe a lot of you touched on this. Someone said frequency, someone said a lot of high numbers and the peaks. So if we're thinking about that, there's a lot of more than one mode, meaning if we said before, there could be one mode where it was 80, meaning 80%, or that's the mark. But it wasn't just 80, there's another number that's very high, could be 60. So if you look in the exam score, where it said there could be 2 peaks. So we could say, for example, there were many students, I can't say exactly how much, but a majority got 90, and many students who got 50. So this would show in your distribution that you would see how many peaks would you see there for in this situation. Yes, 2. Someone said 2. Yes. So in this type of situation, you have 2 groups. So what could you say those 2 groups are?
Fail and pass.
Say again, sorry? Yes, fail and pass are also, we could say, high performers or?
Low performer.
Yes, or students who studied for the exam and students who didn't study. So that could be just an example of how or why you would see more than one peak. It's because there's more than one mode or a higher frequency of numbers or higher frequency of, in this case, exam score, okay? But if you're thinking about how this could relate to finance, I can't tell you off the back of my head, but at least this kind of gives you a reason why you could see a try model in here. If instead of with 90, 50, and there was another number, 30 or 20, right? So it would divide, or you would see 3 peaks. Just one second, I just gotta plug in my computer.
Hello, sir. I
Yeah.
think why here they got the 90%, but not 90 point.
Okay.
For the 50% or so. I think in here they should that the student got the 0.90.
Yeah. So you're basically, so let's say the score was out of 50, right? And so whatever out of 50 gets 90%. So it could be like, let's say 45 out of 50. So a lot of students get 45. So you're right. Okay, but if I just wanted to show you in another way percentage, but yes, correct. So don't get too caught up if you don't understand, but just the main point is there's more than one mode. There's more than one mode because there's more than one continuous or number that is very frequent, okay? Other than a unimod, which only has really one that is more frequent than all of them, okay? All right, so luckily for you, this won't be a major topic yet for you, but it's just to at least get you thinking about, why things happen a certain way. Okay, so I just have to let everybody know at 3:30 I have a meeting with Yoni, and so I'll have to leave. But if you do have questions that you want answered, I can ask here for 4 p.m. Q&A. Do you have a question?
Hey, sir.
Yes.
You didn't. Sorry.
For about bimodals, there is 2 peaks, all right? And how about those peaks? Is it equal each other, or if there is one peak is the higher and one more peak is the lowest or lower? How about it? Can we call it bimodal? Or
Yes. You can call it bimodal because it's showing that it's just not one model. And you can distinguish, you can see that there is another group in there because it's different from the highest peak. Or it could be similar or even equal, but you can say that you can count, okay, there's more than one peak. So you're right. You can say that there are 2 peaks. Again, did you have a question?
Not for now, thank you.
Okay.
I have question. The
Yes.
first one you give the B model. This is what I did search and I see the example. So I want to get another example, and another one is you didn't answer the T model as well.
Okay, so the 3 basically means that there's another group, there's another mode within your data set that has a frequent number or frequent repetitions repeated. So you would see in your histogram that there's another mode or another peak because of that. And another example that we could choose could be related to, actually based what I checked as well. We could talk about height. There was one example about height, and if there could be 2 peaks, and one peak could also be related to the gender. Because if you are getting data sets with a lot of people, obviously it's not just going to be one gender unless you specify this is all males. But if it's male and female, you may see different peaks, or 2 peaks indicating male female. Okay.
Yes.
And another example can be when we're talking about species, right? So there's many different types of species of animals or insects. But let's say we were getting the height or the weight. So we would see different peaks depending on that group of animal or insect and depending on their species. All right?
Okay.
All right. Thank you for your very, very awesome questions. And I'm going to move on a bit and talk about, or here's a question, what is symmetrical, A or B?
A.
A, and how do you know it's symmetrical?
It shows exactly right in the middle of the object.
All right, yes. And if you look at there's a word called proportion, or we can say the size of the parts, the left and right. Could we say?
Right in the middle of the
Yeah, that's right. And how do they look compared to B?
It's A looks a lot cleaner.
All right, cleaner, yeah. Very similar. Okay, nice. All right. So my question that you answered is A for being symmetrical. Okay. Now, the question is, what does symmetry mean then? If A was symmetrical, symmetry would mean.
Symmetry would mean the medium.
All right.
I mean, in terms of the graph, but in the building, it's going to be a different.
Yeah.
The functionality of it.
All right. So we could say symmetry is being equal or balanced proportion of the parts or size of the thing. So that previous picture, we said A was symmetrical because it is pretty even, or if not fully even, and balanced, okay? On both sides, left and right, okay? But we can say B is not symmetrical, it would be asymmetrical, all right? Because they are not equal, not fully equal at least. So it's important to understand that word because it will help you with skewness. So what is another way to say the skewness of a distribution? Does anybody know? It actually relates to the word we just learned.
Yeah. True.
Okay, so another way to look at this is whether or not the distribution is symmetrical or not, all right? So when we look at skewness, another way to say is it symmetrical? Is it balanced? Is it
Skewness is not symmetrical. Skewness
Sorry?
is more going on the left or on the right.
Yes, okay. That's true. That if it's a left skewed or right skewed, it's not symmetrical, right? Correct. All right, so I kind of showed the answers here, but a left skewed distribution has outliers on the left. It's kind of easy to remember that. And a right skewed distribution has outliers on the right. Okay.
Right.
So what is an outlier again?
The outlier is I think the distribution that spread around.
Yeah.
I mean, on each side. I mean, outside of the model.
Okay. Yes. So
And there
outlier.
can be higher and lower outliers. It depends on how it occurs in the data.
Yeah. So I'll give you another example, kind of funny. So in my cohort group, we would joke around and say someone's the outlier, meaning either they don't get along with the main group, or they could be just acting different. So
No, yeah.
it's just another way to give an example of an outlier. So outlier is, again, as you said, it's a bit different from what is standard. So standard being average, or it could be the mean, right? So the outlier is away from the middle, for example. Okay. So let's move on a bit more. And what is the skewness of this distribution below? Would you say it's symmetrical or not symmetrical, and why?
It is not,
It
because
is not.
it left. It's right school.
Okay.
School right, right school. I don't know.
You could say it's skewed to the right or right skewed. And yes, based on your observation, I can see that. But if we were to say, if you've seen a right skewed where it be right to the right and fully to the left where there's a left skewed, and we could say, would this be in the middle?
No, I think the skewness is a little bit going on the right. A little
Okay.
bit.
Yeah. All right. So in terms of the three categories or the three types, which is a right, a fully right, a fully left, and symmetrical, if you could choose one type for this, being symmetrical could be like almost symmetrical or very close. Would you say that this graph is?
Yeah, it's very close.
Okay, very close. So because it's pretty close, it's not fully symmetrical, but we can still say that compared to the other versions that it's pretty symmetrical.
So you make an assumption, is that what you mean?
Well, based on the other types of that, it could be, right? It could be, I'll just show you what I mean. So if we look at these two types, comparing the first and these two, we can say that the first one still has a shape very similar to what is symmetrical. And if we look at these two, on the left, what would it be, a left skewed or a right skewed?
I mean, on the left one, it is a right skew.
Okay. And on the right, you're saying it, sorry, you said left.
The right
is
one
right.
is the left skew.
All right. And everybody else?
Yeah, left is right, right is left.
Okay. And so if that's the case for this one here on the left, the outliers are located where then?
Yeah, that's the outliers on the right.
Okay, on the right, and this would be on the left. Okay, let's check it out. So this one is right skewed, and we have a left skewed. And we have our outliers on the right as well, and outliers on the left as well. Okay, so if you do see this, you can identify it, but we won't go to a depth about, actually will later, about why it might happen. But at least you'll get to see the three different types. That generally, when you look at it, you could say, hey, this is symmetrical, this is good. Or if it's left skewed, they might tell you something. If it's right skewed, it's a red flag that something could be wrong or something's happening. But we'll go into that a bit later. So we're going to skip this group activity for now because we're going to leave it for homework for this one. And the questions are going to ask you what might cause a left or right or symmetrical distribution.
I also have question related to this. I want to ask you what it happened to the left and the right. Now you give that question already.
I gave it to you, and you can see maybe there's something in the data set, the values, okay, that is causing this to happen. All right. So this will be a little small homework that you can research and then just tell us what you have for it. And we have about 17 minutes, so I want to go into this one. And this is moving away from SKU now, okay? We're moving on. So blank is a statistical measure used to describe the degree to which data points cluster in the tails or the peak of a frequency distribution. Now, the main words here, tails, peak, and what word could go in here?
I have a question, sir.
Yeah.
So when you say tails, does it mean peak or something different?
So it means something different, sorry. Peak would be at the very top and tails would therefore be at the bottom. Sorry, I didn't clarify that.
Okay. It's like the outliers you see? The tail?
Yeah, that's another way to put it.
I see. Thank you.
Yeah. All right, I think if I told you what the word starts with, you might know. It starts with a K.
Yes, someone asked in the group already.
In the chat?
Yeah, in Telegram. It's kurtosis.
Oh, yes, correct. Kurtosis or kurtosis. You could also say kurtosis. So I'm going to ask this question first. The something is the tallest part of the distribution, and the something are the ends of the distribution. What do you think?
Please you
okay,
the question below, statistical measure used to describe. Now, what is it? Histogram or?
it's it's kurtosis.
Could you tell me about the space, the answer of blank below? Oh, kurtosis.
Yeah, sorry, I forgot to do that. Okay, so kurtosis, that's the definition, but what is this one is the tallest part? And what is the ends? So we have the first letter.
So you mean these two known as kurtosis?
Yeah, they are features of kurtosis.
So whether it is tails or peak, is that correct?
Yes. But when we're talking about kurtosis, we're talking about two things about it. One is, you said it, peak. And what is the other part?
Tails.
Yes, tails, correct. So the distribution of those 2 points. So here's show you a picture here. So we have our peak here at the very top, which is at the very tight. And then we have our tails. We have one on the left and we have one on the right. Okay. Now, depending, this can look very different. And as you probably know, there are different types depending on how these are distributed. So first, let's go with this one, which might help us. Let's try the first one. A something has a something, starts with peak, and lots of extreme values. This is often seen in finance and in the stock markets. All right, so there's a type of kurtosis, a name for it, that has narrow peaks and lots of extreme values, which could be outliers. Let's try this one. If you can't get this one, let's move on to this one. A something is something that looks like a bell curve from a normal distribution. And the third is something has a BRO peak and a few, only a few extreme values. Can anybody fill in the words for any of these three?
Mostly one sentence, they just give us guess only one word. But now you one sentence for 3 words. So
Yeah,
I mismatch for it.
yeah, that's fine. Try to get one then, if you can. One word, I mean. All right. Is it okay if I show you the answer? Or do you still want to try? Okay. I'm just going to show you the answer because if I showed you the picture, it would have been easier, but I skipped that. So a leptokurtic has a narrow peak and lots of extreme values. A mesokurtic is something that looks like a bell curve from a normal distribution. And platykurtic has a broad peak and few extreme values. Now I'll show you a picture very soon, but we can say a mesokurtic, is it symmetrical? Would you say it's symmetrical or not symmetrical in this case?
Oh, I can guess see but right, but I'm not sure. Narrow and extreme, but I don't know the meaning.
Okay, extreme? Do you want me to explain about the word extreme?
No. Because you give us to guess, I guess see but narrow and extreme. So I guess see correct, but I don't know what exactly is meaning.
Okay, no problem. Okay, so now hopefully it's just another way to learn these terms. If you're not familiar with the terms, it's okay. I think if you were familiar with the terms or the types very clearly, then this would have been easier, but I kind of want to make it harder a little bit. Now, we have these 3 types here, and if you can maybe think about which one would be leptokurtic, which one would be mesokurtic, and which one would be platykurtic, based on their definition and what you see.
I think the middle one is leptokurtic.
All right. And why would you say that?
Yeah, because the peak is very narrow. It's not wide.
All right, that's a perfect description. So I would also agree that the middle one is leptokurtic. So if we know that, what about the other 2 on the left and right?
Let me think about it.
The last one on the right.
What do you call it? Yeah, Kia. Last one on the right is which one?
Okay.
I mean the second A. That looks like a bell curve. Yes.
Okay.
For me, the picture number 1 is polytutic, has a broad peak and 2 extreme value, and the third one is a lithocutic, leptocutic.
Okay. All right. What about Cadet?
Yes, according to the data cam lessons I see, the text is the first one. First one is the text, and sorry, the middle. Right, all right. The middle is the lateral cortex. It looks like a narrow peak. Look like a narrow. It have a strong peak, strong in breathing. As we see on the first questions is extreme values, and the mesocortex is the last one. Something look like the bell curve from normal distribution. And the last one of question is plenty cortex. Has a broad peak and show extreme values.
All right, thank you. So let's check it out. The one on the left here, P for platycortic, and L for leptocortic, and M for mesocortic. So for P, the key word here is broad, and broad meaning that it's pretty much wide, and you can see that there are actually some high values here compared to the leptocortic where it's very narrow. So you can see it just gets really small. It's not broad. So it's really the opposite of platycortic. And mesocortic is, if you think about the bell curve, and has a very much a normal distribution and very much symmetrical. So now, just 1 second, I have to check the time. 6 minutes. Okay, so let's just end it with this slide. You can see them, all three of them together. Mesocortic being green, platycortic being a little turquoise, lighter green, and then the red being leptocortic. And so these are the general forms of the 3 forms, right? And these all relate to what is going on with the data, meaning this one has leptocortic can have extreme values, and this one has less extreme values, but it's very broad, and we have this normal distribution. Now you'll see here this plus and minus will also tell us something else related to the outliers. So for a platycortic, you'll see that the outliers are negative, and for this reason, the distribution will have thinner tails being at the end, than a normal distribution. And if we look at a leptocortic distribution has outliers that are positive, okay? So meaning that the number is a positive number, not a negative, okay? So I'm gonna have to end it there, but I wanted to get some feedback. I also wanted to ask if you wanted a Q&A session so I could tell Kia. So first question is, I know there were some hiccups from my end, apologize for that. My only excuse is that they just gave me, I had to do these slides from 10 a.m., I think, or 9:30, 10:30. So I didn't have much time to make it really amazing, but hopefully it's something that, you know, gives you a different perspective of how to learn, maybe better than data camp. Now I'm just looking for some feedback, honest feedback about it. Do you want to continue this way? Is it too slow? How can it be improved? And I can talk to Yoni because I already know, you know, learning from data camp being by yourself, it's not the way to learn. You can just do it at home and you don't have to pay. But I just want to get some feedback. Is there anything you want to add? Is this how you want to continue, or okay? Yes, Lisa.
Okay, so the way you instruct us is good already, but it would be better if you include like how we could apply it in our real life, in our real example.
Yeah.
Like we have many different terms, but how can we make use of it when we analyze our own data, or we can't use it at all, or just for general knowledge, or what?
Yeah, that's a good one. I think the reason behind they did this first was to ease you into Excel when you start to use visualizations and also some of the formulas and graphs to better understand if you're using them in context. It would be nice if you could learn and then do Excel at the same time. It would be like you would understand it better. However, this is how we have it for now. But thank you for the feedback. And I will try to do that for next time to include more examples, possibly related to how this applies in Excel. So. And okay, so I have to cut it there. Do you guys want a Q&A with Gia?
As I see, lecture text, plenty text is refer to the kurtosis value, which is negative, and lecture text refer to the kurtosis value, which is positive.
Yeah.
Yes.
Yeah. Got it. Okay, so I'm gonna give. I have to talk to Yoni about just about the first day. And do you guys want to talk to Gia? Do you want to message her and you want a session with her, or are you okay for now? If anything, you can drop it in the group if you want it. Q&A with her. I'm going to clarify if we're going to continue this tomorrow, because there's 4 chapters. This is only on the first chapter and there's a lot of content, but I'm going to see what's up next. And if you do want to continue, you just have to tell us, or if you kind of want to move on, because tomorrow is supposed to be Excel, but there's still a lot of content in the 4 chapters. So you just have to tell us that, okay? Okay, so
for me, because I didn't finish all the course yet in the morning yet now, and for you, just you prepare your slide and you do the way that you present is good. I think it's better than the boot camp, because we have the teacher, we have the trainer to guide us, and we have questions we can ask, and later on we can learn self-study by the boot camp. Later is good.
okay, thank you for the feedback. I'll tell you only that. And I'm going to try to push for this, guys. It's just I have to try to like do as much as I can to make these slides. And I did prepare for Excel a bit. So this one was just like, they just told me to do it. So I didn't have much time to prepare. Okay, so I have to go now. Thank you so much for your questions and being engaged. And I hope to continue like this and improve. So I'm gonna end it here, and you'll just have to send a message to Kia if you want a Q&A, okay? Because I haven't heard from all of you yet. But if you don't say anything, then that means that you don't want the Q&A today. Maybe you can leave it on, okay?
Are you saying end of the class, without Q&A today?
So I have to go now because I have a meeting with Yoni, so I have to end it here. And we can continue it if you want to continue with the visualization. But if you want Q&A, you just have to tell me, or you have to send a message in the group like, we want a Q&A.
Oh,
For
okay.
me, no.
Yeah.
Oh, okay.
No, I'm good.
All right, great. So I'm gonna try to update you as soon as I can when I find out what's going on tomorrow. But with the schedule, we're supposed to install some software. But if you guys want to want more review from me for this, I can create some more slides. You just have to send me a message, private message. I can tell you only, okay?
Okay, so that's it for today then.
Yep, that's it. All right.
Okay,
Okay,
okay.
thank you.
Thank you, everybody.
Okay, for tomorrow we're gonna meet you again at 9 or 9:30.
I believe you're going to meet Sing Hong because Sing Hong and Lee Meng is going to guide you through some installing new software, I believe. And then you'll meet me for Excel
Okay,
at 1 p.m. And we're going to go through the Excel course in terms of what we're going to learn and what we have to do. Okay?
okay.
Okay, see you.
Yeah.
Okay. Bye, everybody.
Understand.
Thank
Thank
you.
you.
Thank you.
Thank you.
Bye.
Bye.
Bye-bye.
Thanks so much.
Welcome.